Hey guys. All right. For assignment 5, I built, the lane detection algorithm in Python using OpenCV, following the pipeline in the course. The overall goal was to detect lanes in a street, right? And estimate like true boundaries of where the road goes. So the basic pipeline used was the same one in class. It was, so load the frame, snip the region of interest, and then apply a polygon mask that is a trapezium, basically to isolate likely lane markings, and then convert it to grayscale, HSV, do the mask and the HSV, then convert to grayscale, apply a threshold, blur the image, detect the edges, and then run a Hopf transform, which basically assumes where a line is given a set of points. And it's a transform that makes dots into lines and lines into dots, meaning that if you have a bunch of dots, more or less pointed together in a specific direction, their intersection point after the Hopf transform will lead to the line that best suits them. And then separate left and right lanes. Basically, try and estimate the true left and true right using a median. Pretty simple. Find rho and theta values to basically find the angle we want, and then draw those lines on the frames. The first important step was defining the region of interest. I don't want the algorithm to look at the full frame or the sky or the hood of the car, especially the hood of the car, because they're not useful and they basically introduce a bunch of noise that messes with it. So crop the lower roadway and then apply the trapezoidal mask so the algorithm focused only on the part of the image where their lanes actually realistically appear. After that, I used color and intensity information to isolate the lane markings. Depending on the video, I either used HSV masking or relied more on grayscale thresholding. For some videos, especially when the lighting was more stable, HSV markings basically helped isolate yellow and white lane markings. But for other videos, especially brighter ones, especially the later ones, and the gravel one, the HSV masking was less reliable because lighting conditions and glare and pavement reflections changed the apparent color of the lane paint. In those cases, gray thresholding actually worked better. Once I had the masked image, I converted it to grayscale and applied a binary threshold. Right, this reduced the frame to bright lane features, and then it was just a dark background. Then blurred the image for a Gaussian blur for the next step, because then with a Gaussian blur, anywhere there's a sharp derivative between the color, between the bright and the dark, is an edge, which you wouldn't get before you blurred it. So it just helped edge detection. So, and it also reduced noise. And then next, canny edge detection, that's that gives the outline of lane line features. And after that, it's just cv2.huff_lines, I think, which returns lines in rho theta form. Since the Hopf transform usually detects many possible lines, you just had to decide which one was the true and which one was the right, left and right boundaries. And then basically the way I separated left and right was based on the theta. After the Hopf transform, I basically split the detected lines into two groups using angle ranges. One angle range was treated as the left lane, and then the other range was treated as the right lane. And then instead of drawing every detected line, I basically estimated which one was the actual one using the median. And then it gave a lot more stable results. And basically matched what the assignment wanted. So that's more or less it. The first and second videos were the easiest. The last two, especially the gravel road was the hardest. And basically, to like finish it up, let's just see some of the videos. I don't know if you can see it, but that is it tracking, right? And then if I want to see like another one, let's see that one. As you can see, it matches one and the other, back and forth and back and forth. It deviates a little bit. That's basically just like the noise affecting it, but more or less, it more or less knows where the lane is. And thank you for watching.